Ugh. Okay. So I said we'd go over this, right? So let's go over this so I can go back to watching Alabama beat up Texas A&M. All right. I think this was the homework that I gave you. If not, uh, too bad. I don't know. Okay, we can do these anyway. This is gonna be fun, right? Fun. Okay, so fill in the blanks, complete the proof. Angle HKJ is a straight angle because duh, it's on a line. And KI bisects that angle. I want to prove that IKJ is a right angle. Alright, so this is pretty straightforward. If this is a straight angle, we know this adds up to 180. And if it bisects it, that means that this should be the same as this. And so if you split 180 right down the middle, that's 90, which means this should be a right angle. Should be. So let's go through the steps we can prove. So what is given to us? There's two things given to us, two steps that say given, so we can use some common sense to figure out which one should go first. So if step 2 says HKJ is 180 degrees, that means our first given should regard this straight angle here. So we can say angle HKJ is straight angle. Alright, so step 2, the measure of that angle is 180 degrees because that is the definition of a straight angle. Any straight angle is going to be 180 degrees. Alright. What else is given? Well, this ray KI bisects HKJ. Alright, so then IKJ, this angle has to be congruent to IKH because that's what bisectors do. They split it evenly, making them the same. If the angles are the same, that means the measures of the angles are the same. That's the definition of congruent angles. And then our angle addition postulate says that we can add these two angles together. So the measure of angle IKJ plus the measure of IKH will have to be the same as the measure of both of these two together. Okay, so it's going to have to, we take these individual pieces. What color haven't I used? Let's use green. So IKJ plus IKH has to equal the entire distance across. That has to equal the measure of angle HKJ. Alright. This next part, this is where it sort of gets a little crazy. How do we go from this to this? Alright, so let's look at it. The measure of HKJ is 180, right? So that's where this comes from. Alright, then 2 times the angle of IKJ. 2 times that measure. Well, we have IKJ. We have that. How did we get double that? Well, if we look, IKJ is the same as IKH, which means anywhere we see IKH, we could actually replace that with the measure of angle IKJ, which is also that. So instead of putting IKJ plus IKJ, you just say 2 times that measure. Alright? Hopefully that makes sense. If not, rewind it. Watch it again. Okay, so what steps did we use here? This came from, we knew HKJ was 180. That was from step 2. We knew that IKJ was IKH from step number 5. And we substituted all of this on the left side from what our information was in step 6. So we used all 3 of those steps to come up with this part here. Alright, let's move this out of the way so it looks ugly. Alright, so we get from 2m to just 1m by just dividing out this 2. So that's the division property of equality. And then IKJ is a right angle because the measure is 90 degrees. That's because that's straight up the definition of what a right angle is. And Success. That's what we wanted. That's what we got. Smiley face. Okay? Okay. Alright, so we're going to go to the back side of this paper, and it says write a flowchart proof. And everything I've seen says don't worry about flowchart proofs. Until I hear otherwise, we're not going to worry about flowchart proofs. It's basically the same thing. It's just done in a different way. And we already have 2 ways to make proofs. We don't need to make it more complicated than that. Right? Okay, so I'll turn the sound off. Hopefully you couldn't hear the football game. That'd be silly. So we're going to write a paragraph. So forget flowchart. Paragraph. That's a lot more fun. And then afterwards I'll put up the answer for the flowchart so you can see it at least and be like, oh, so that's a flowchart. I'll be like, okay, so let's go through our steps here. So if we want to write a paragraph, we need sentences. So we can say, start with number 1, angle 1, and angle 4 for supplementary. As well as angle 2 and what's that and? Never mind. Let's just write the and. That was bad. So angle 2 and angle 3 are also supplementary. And why is that? Well, it says linear pair theorem, or we can actually look at it and see, well, 1 and 4, those 2 make a straight line, and 2 and 3 make a straight line, which is where this linear pair theorem comes from. So because of linear pair theorem. And again, I mean, this is open to however you feel like writing, so you can change these words around. I'm not really the best with words. I had to pick whatever words I feel are good. Okay? So our next step. This is a given part. This is pretty straightforward. So we can say it is given that angle 4 is congruent to angle 3. And that's all it gives us, so womp womp, that's it. Now what? So we look at our next step here. Angle 1 has to be congruent to angle 2. So this can be a little bit confusing. So this is the congruent supplementary angles theorem, or supplementary sides. No, angles, angles, supplementary. It doesn't have to say angle because supplementary only means angle. I hope I made that super confusing. So why does this work? Let's look at our picture. So angle 1 we're saying is the same as angle 2. Okay? And we know that because what's given to us is that angle 4 is the same as angle 3. Right? So if these are the same, it means I can switch them around. I could say that 1 is supplementary to 3. So if 1 is supplementary to 3, so 1 and 3 are supplementary as well. Well, if 1 and 3 are supplementary, we already know 1 and angle 4 are supplementary. Then that would have to mean that 3 and 4. Oh, dude, I just gave you what it said. All right, so 3 and 4 have to be the same. Blah. I'm gonna take a quick break and just sit here. You're gonna sit here too and be like, I know what you mean, or I don't know what you mean. Explain it better. And I'll say, shut up. Okay, so quick break. Go get some drinks. That's some tasty water. Okay. So we can just keep going here. We can say 1 and 3 are supplementary, 1 and 4 are supplementary, angle 2 and 3 are supplementary, and 2 and 4 are supplementary. Okay. So now if we can look at the comparisons, between all these, right? And knowing that 4 and 3 are exactly the same means we can swap these around pretty well. It means that angle 1 and angle 2 are the obtuse angles, and 3 and 4 are the acute angles, and that combined, it always adds up to 180. So if our acute angles are the same, that means our obtuse angles have to be the same, which is where this comes from, and that's basically comes back to our congruent supplementary theorem. Okay, so let's put that into words. Okay, so we can just say angle 1 is congruent to angle 2. Let's use the word by. I haven't used that yet. By the congruent supplements theorem. Sups. Alright. And then our last one, let's close this up. If angle 1 is congruent to angle 2, that means their measures have to be the same, so we can throw in a sassy little therefore. The measure of angle 1 must equal the measure of angle 2 by the definition of congruent angles. So we just took our last step, which again is what we tried to prove. Since we proved what we wanted to prove, we're all done. Okay? Alright, I want to try something. So I think this will come out ridiculous. What happens if I try to take my paragraph and change it to regular handwriting? Let's see how good it is. Whoa. Not quite. Sap. Alright. So that's that. I said I would show you the flowchart version, so the flowchart version is coming up right now. Let's make this bigger. So it's basically the same thing as a 2-column. All it is, and this one, I mean really the only benefit of this is when it skips around. Like remember here where step 7 came from 2, 5, and 6. Instead of having to write steps 2, 5, and 6, if we used our flowchart method, we could have just drawn arrows from box 2, 5, and 6 and drawn them all going into step number 7. So that's what this is. You put the statement in the bubble and the reason underneath the bubble. And then any statement that goes with our next step, you draw an arrow to it. And then generally speaking, you work from top to bottom still. Top. Let's pretend that's a straight line. And then any extra stuff you can put off to the side like that. I guess you could go left to right too, depending on how you flowchart. And if you ever get into computer science, you get to do flowcharts a lot more. Or, I mean, really, anytime you do logic, you do flowcharts. But not now. Maybe later. Maybe. Okay, last one. Use a 2-column proof to write paragraph proof. Yes, paragraphs. Who doesn't love to write? So, let's take a look. So, it helps. We don't actually have to prove I don't want to say prove anything, but we don't have to prove anything on our own because it's done for us. We're just basically plagiarizing and writing it all fancy like. So AB equals CD. Okay. BC is DE. Prove that C is the midpoint of AE. Well, duh. I mean, if this is the same as that, and the little piece is the same as that little piece, if we add AB and BC, it should be the same as CD and DE, which is what probably all this says, if I bother to read it. Okay, so let's start. So it says, it is given that AB equals CD, let's see, and BC equals DE. And let's get fancy. I'm going to put a comma in here. Alright, ready? And we're going to go right to the next step. So, by I should probably use all my letters. By the definition not the definition. I'm sorry, that's not the word I wanted. So by the addition property of quality, AB plus BC has to equal what does it have to equal? Well, there's two things we could put. We could put this equals AC, or we could put what's up here and say that's equal to everything on the right side. So CD plus DE. Okay, so that gets us our first two steps here. All right. Oh, then it does it down here. Okay, so I guess the order doesn't really matter. So we can also say by the segment addition postulate, AB plus BC is AC, and CD, I can do this better, and CD plus DE equals CE. Alright, so notice, usually we go statement, reason, but you can also mix it up sometimes and go reason, then statement. And nobody's going to complain at you. As long as you get everything in here. 'Cause the question I thought to myself is like, how do I grade these? I don't want to read every paragraph. So what I'm going to be looking for is, first of all, do you get the answer? That's the important thing. Do you skip a bunch of steps? That's another thing. And then for every step, do you have step, explanation? Step, explanation, step, explanation, explanation, step. As long as you have it all, you'll be good, right? Okay. So our next step says AC equals CE. Well, how did we get that? Because we know that if this is equal to this, right, then we can replace what am I looking at here? Falling asleep. Sorry, I'm getting distracted watching Texas A&M get beat up. They're down by 3 touchdowns. Yeah, 3 touchdowns. So, okay, so CD plus D is the same as AB plus BC. So we could put that CD plus DE equals AC by substituting. And we also have just the straight up fact that CD plus DE equals CE. So if CD plus DE equals AC, and that also equals CE, then we can simply substitute and say that AC has to be CE. So it's just substituting, because these are exactly the same, which is why we can interchange them here. Okay, so then our next step, we could write that as, let's get fancy, therefore, you ready for this one? Substitution, ready, yields, it's a fancy way of saying gives us AC equals CE. Alright, that's fancy stuff right there. Okay. And then this should be pretty straightforward. If the measures of the sides are the same, then we can say by the definition of congruent segments that segment AC must be congruent to segment CE. Alright, And if they are the same, if they are congruent, and from A to E, that's our total distance, right? Then halfway in between has to be C. So if AC, the distance on the left, is the same as the distance on the right, or these segments are exactly the same, then C has to be the midpoint. Okay? So one more fancy word. Let's say thus C is the midpoint of AE because of I'm thinking of what words I want to use, and I don't want to make up stuff because of the definition of a midpoint. I guess there is an abbreviation for midpoint. Doesn't really save us a whole lot though. Okay, so all we did, we took all of our fancy steps, wrote them into sentences, put colors on them, used bad handwriting, drew some check marks, underlined some stuff, and we have our final answer. So we can put a little happy QED. Now he has a nose. He's like a snowman. Let's give him a hat. Alright, that was fun. Was that fun? Maybe. I don't know. Anyways, we'll see you on Monday. Like, comment, subscribe, share on Facebook, all that good stuff. Okay, bye.